Okay, so this is chapter 6, part 2, and again, we're talking about metabolism. This is a relatively short section where we're going to focus on the laws of thermodynamics. And so what is thermodynamics? So thermodynamics is going to be the scientific study of energy and energy transfers and transformations involving physical matter. Okay? We use a couple of terms here that I want to make sure that we're familiar with before we jump into the two laws. You will hear me say system. So when we're talking about the system, it's whatever is being studied. And the surroundings will be everything outside of the system being studied. There are two types of systems, open and closed. And so an open system is one in which energy can be transferred between the system and its surroundings, where a closed system is the opposite. Energy cannot be transferred between the system and its surroundings. And so I got a little picture of this on the next slide, but you should know that biological organisms are open systems. And so biological organisms can transfer energy between itself and its surroundings. And so therefore, living organisms are subject to these laws that we're going to talk about in just a second. And so here's just a little picture showing you the difference between an open and a closed system. So again, living organisms are open systems, and we are able to exchange energy or transfer energy with our surroundings. Okay? And a closed system here is one in which there is not energy transfer. And so in the laboratory, we can create closed systems. But again, in the real world, when we have living organisms that are not in a laboratory controlled setting, we are considered to be open systems. Okay, so that brings us to the laws of thermodynamics. And so the first law, which is also known as the law of conservation of energy. This law states that the total amount of energy in our universe is constant. There's always been the same amount of energy. There always will be. It states that energy cannot be created, nor can it be destroyed. It can only be transferred and transformed. Okay? And so in this picture over here on the right, I'll start on the right-hand side where we have the sun. So we say that the sun, again, is the ultimate source of energy for our planet. That energy is in the form of light energy or wave energy. And that energy can be captured by photosynthetic organisms like the plant shown here. And it can be transformed into chemical energy stored in the bonds of food molecules like glucose. Okay, so energy was transferred from the sun to the plant, and it was transformed from wave energy to chemical energy. Here's some kids, some humans, and kind of a poor choice of food, but it is what it is. So we've got an ice cream cone here coated with sprinkles. And so this is an example of chemical energy. Okay, and when kids or humans, whatever, eat that food, that stored potential chemical energy, that energy can be, so it's transferred from the food to the individual, and it is transformed from chemical stored potential energy to the energy of motion, shown here, kids riding their bike. So that's kinetic energy. So energy can be transferred and transformed, but energy is not created, nor is it destroyed in the process. For living organisms, it's a challenge, a constant challenge. We have to obtain a constant flow of energy from our surroundings in forms that can be captured, can be transferred, and then can be transformed, right, usually into ATP. And that type of energy can then be used to drive all cellular work. Okay, so, why do we need to eat? To obtain energy, right? And other nutrients from food. But again, that is our fuel source. And so it's important to also select the right types of fuel, hopefully not ice cream, so that we can get the most, bang for our buck, the most energy out of that food. Okay, last slide here. So the first law stated that energy cannot be created nor destroyed, right? The energy of the universe is constant. It always has been, it always will be. Energy can only be transferred and transformed. The second law states that with every energy transfer or transformation, that some energy is going to be lost. Okay, so in other words, no energy transfer or transformation is 100% efficient. Okay? And so when we say some energy is lost, it's going to be lost in the form of heat. And that's going to increase the amount of entropy in the universe, which is disorder. Okay. And so living organisms, again, we need a constant supply of energy. And when we have energy, we can maintain order and organization. And so you can think of living organisms as these kind of islands of low entropy in a universe that has entropy constantly on the rise. Okay, so again, we need a constant supply of nutrients to transform, into ATP so that we can continue to live. Okay, and we'll see when we get to, for example, cellular respiration, there is more energy stored in the bonds of glucose than we are able to extract. And so, during cellular respiration, somewhere in the order of 32-ish ATP are produced. But again, a lot more ATP potentially could be produced if that process was 100% efficient, but it's not. Some of that energy, some of that chemical stored potential energy will be lost and will increase the entropy in the universe. So that is it for the second part of the chapter on thermodynamics. Next part of the chapter, part 3, we will focus on ATP.